Okay, well, hello everyone, and welcome to our game development stream. Um, what I'm going to be doing today is building a block game based on or inspired by Minecraft and similar games, and this is running on the Convex blockchain. So, what I'd like to start off with is just a very quick demonstration of what we're building. So, I'm going to go into my Eclipse environment, and I'm just going to run the game just to give a little tour of what's happening. So it's just booting up and it's generating the world, creating all of these chunks, and you can just see that scrolling down on the output window there. And it's just about to boot up, and here we are, we're in the game. So this is a voxel based game. The entire world is made of these nice little colourful blocks, and I can fly around the world. I'm sort of like in a disembodied spirit mode at the moment, but I can see everything that's going on. I can zoom in, I can zoom out, I can move up and down. And if I want to, I can place some blocks in the world. I've got a collection of different blocks that I can use. So let's say I want to build this grass out a little bit more. I just right click, add some blocks, and build away to my heart's content. Now, if I run out of blocks, then I can't build any more with that particular type of block. So if I want to get some more, I'm just going to have to pick some up. So let's pick some up here. Pick up a few different varieties of blocks. And there's a little bit of a graphical glitch going on there. I think it's not refreshing all of the vectors, but we don't need to worry too much about that. So as you can see, I've now got 24 of these grass blocks. And then I can go back over here and I can continue building. So let's just build this out a little bit towards the edge of the screen. Okay. Now, we can also have a look at what's happening underground. So as you can see, we've got some cave generation happening. So I can just here see into the top of some kind of cave complex. Let's just go and have a look inside, see what's happening down here. And wow, we've actually got quite a decent sized cave just sitting underground here. So if you've played Minecraft, the cave generation maybe looks a little bit similar to that because we're using some similar techniques. We're using Perlin Noise and procedurally generated patterns in order to build these underground rooms. And as you can see, some rooms are like these sort of these big open areas, but we also have these like little corridors. So let's go down here. We have a nice long corridor going all the way down here. And at some point, we're actually going to get to the bottom of the world. And currently, there's nothing at the bottom of the world. It's just you're going to fall off into empty space. So if I go down here, in fact, we can see that the world kind of stops about 32 blocks below the surface. But it's quite nice. You can sort of see the different caves, how they cut out from the rock. And let's zoom up in here again. And you can sort of explore these sort of underground worlds. So currently these caves aren't particularly interesting. There's not too much in them, although we do have some nice little rock layers which I quite like. So again, this is all procedurally generated, and you can see that most of the time the rock layers stay on the same level, but at some places we've got a little bit of variation. So at this point, this light-colored rock layer goes down an extra level and sort of continues on over here. So we get this sort of slightly natural appearing sense of the rock textures. So if we go to the side of the world, you can see that the rock textures are sort of mostly on the same level, but we've got this little bit of variation now and again. And again, this is all done with 3D Perlin noise kind of functions to add a little bit of variation to this space. And we do have water, but currently the water doesn't have any physics, so it just sort of stays up in the sky like a regular block, which is a little bit weird, and we're going to have to tackle that at some point. But it doesn't cause too much problems right now. And also we've got this sort of effect where if the surface has a different layer of blocks. So most of the time the surface is going to be this sort of green grass block, and you can sort of see the underside of those blocks here. Okay. Now the other technique is if you fly into into one of the walls, you can sort of get a bit of a larger view of what the caves are looking like. We can see, okay, we've got quite a lot of big caves here. In fact, a few of these sort of corridor kind of caves. And what we're going to do today is work a little bit on the cave generation and see if we can make this a bit more interesting, add a few more features to the caves. And we're going to be doing that with some code, but also dropping in and out of the game in order to explore a bit more and see what kind of effects we're getting. So the first thing I'm doing is just thinking a little bit about, okay, how would we want to improve this? What could we do to the caves that would make it a little bit more interesting, a little bit more variation, I guess, in the style. So I think one of the things I'm noticing is that a lot of these caves are they're kind of similar size. Yeah, the big blob caves are maybe about 10 blocks high and maybe 20, 30 blocks wide. They go up and down a bit, but they're mostly got the same kind of structure. And I think we want a little bit more variation in the size of these caves. We want some small caves, and we'd also like some really big ones. So I think the first thing we're going to do is have a little look at the code and see how we can add a little bit of variation in cave sizes into the world. So I'm just going to press escape and quit out of the game. And then we can go into the coding environment and have a look at how we can affect some of these things. So one of the things that we have is this this world generation class, and it has a number of different sort of parameters, and these are all the parameters that determine how the world generation works. And they're currently all constants, but we can do all kinds of different things. Like if we want to make, let's say we want to make very small blob caves, so we want to compress them together and make them smaller, we just reduce the scale of the blob caves. So let's just put that down to 20, and let's have a quick look and see what that does in the world generation. So yeah, just running the world generation again, it takes about 5-10 seconds, not too long. Though we might want to try and think if there's ways we can speed that up so we can get into the game a bit faster in the future. Okay, let's have a look around. Okay, and now we can see that the caves have become much more noisy. There's a lot of these sort of smaller blob caves, looks about 4 blocks high, maybe 8 blocks wide, something like that. And they're all over the place. Yeah, so we've got these caves, literally everywhere. Probably a bit too much, in fact, because you don't want the entire thing to be like a sponge of caves. But it worked. We changed the scale of these blob caves, and we can we may be able to work with this. So what I'm thinking we want to do is we want to add some variation. So in some areas of the map we're going to want the blob caves to be large, but in other areas of the map we're going to want them to be more small. So what we're going to probably do, I think, is put in some variation, again using one of these Perlin noise functions. So the noise function is going to go up and down, and when the noise function is high, we're going to have big caves, and when the noise function is low, we're going to have small caves. So let's get into it and see if we can make that work. So I'm just going to quit out of the game again. So we've got this blob scale of 20. I mean, that seems to work for the small caves. But let's say we want, let's say we're going to want some variation. So I think the 60 was a reasonable size. Maybe let's make this happen up to sort of 80, I guess. So what we're going to do is we're going to take this sort of basic blob scale, and then we're going to add variation up to 80. So it's sort of going to vary between 20 and 100, and 60 would sort of be in the middle of that. Let's also, I'm just going to tweak this one slightly. This determines, at what level the caves start to appear. I like that a little bit higher because I think we're getting maybe too many caves at the moment. Let's make that 0.35 at the moment. That's probably a good guess. But a lot of this is guesswork. Yeah, often you're just thinking about what the world is looking like and understanding what the parameters do and saying, well, okay, how do I then tweak these parameters a small amount just to get the kind of effects we want? So we've got the blob scale and we've got the variation. Now the question is how quickly should it vary? You know, I think we want it to vary quite slowly. So let's have a variation scale, and let's say we want it to vary every 300 blocks or something like that. So it's going to be maybe 200. But so maybe 200 blocks away, it could have a completely different sort of scale. But when you're close, the scale is going to stay quite close to what it was in the adjacent blocks. So I think those are all the parameters we need. So let's go down to the important function here. So the important function is this actually it's a really short function. It's just maybe 10 lines long, and it's this Boolean function that says isCave, and isCave is saying, well, look, for any of the blocks of rock that we're putting in underground at an XYZ coordinate, do we want that to be a cave or not? And we've said that we want to vary the size of these blob caves. So we have this cave blob scale in here, and these are the blob caves. And actually, I better put in a comment here. Yeah. So these are blob caves, which are the sort of the blobby shaped ones, and these are the wire caves. These are the sort of skinny ones that connect things together. So I called them wires because they reminded me of sort of a network of wires running underground. So we're going to want the cave blob scale. So currently it's at 20, but we're going to want to vary that between 20 and 100. So let's make that into a local variable. So let's call that blob scale, and we'll start off by just setting that to the cave blob scale. But we're going to put that in here into our actual generation function. So let's put blob scale in here, and we're going to want this to vary. So, well, how do we make things vary? Well, we're going to use a noise function. So let's create this noise. So the noise function is, let's call it blob scale noise, and we have to use this noise function, and the noise function is going to create a value between 0 and 1. So let's put our XYZ coordinates in here. And we need to say how quickly this noise is going to vary. Now we did that, yeah. We had this variable called cave blob variation scale, and that's going to set the size of the rate at which the noise varies. But we also need to give it a seed, so we just have this seed function. And we can put any number we like in here. If we give the same number, we'll get the same pattern. So I don't want the same pattern of anything else, so I'm just picking a sort of random number here. And what we want to do is we want to say, okay, we're going to generate this blob scale noise, and we're going to have cave blob scale, and we're going to use this noise scale function. So blob scale noise. And let's multiply that by our variation, our amount of variation. So cave blob variation. Now I think, so this number here, that's 20, so the basic cave blob scale. And the variation is at 80. So what this should do is, if blob scale noise is going between 0 and 1, then blob scale should be going between 20 and 100. So and that's going to be varying the scale on this value. So this is going to be interesting. I don't know what this is going to do. First time I've tried this, so let's see what we get out of this. Now it might interact in some weird ways, so we might get some strange effects. So let's see what happens. Okay, this looks a bit crazy. Let's see what's happened. Okay, this is all over the place. So something's definitely gone weird here. We've got what's happening. Looks like we've got still some wire caves going through as normal. Yeah, that's some kind of wire cave. But all of our other caves have turned into these like really tiny caves, which is probably some kind of bug. So wonder why that's happened. So we're gonna have to have a bit of an experiment and have a look at the code and see what's happened. It kind of looks like a sort of Swiss cheese sort of thing going on here at the moment. Okay, so first attempt didn't quite work. So what's happened here? So we've got our blob scale varying between that's a noise, so that's going to be varying between 0 and 1. Our variation is 80. Blob scale noise. So yeah, I think this should be returning something between 20 and 100. But okay, so this is clearly a bit too wild. So let's just maybe do an experiment. Actually, let's put the variation to 0 and see if the variation is what's actually causing the problem here. So if variation is causing the problem, then obviously that's why we're seeing all of this this effect. So let's go down. Okay, and that's back to where we were, I think, where we had just the scale at 30. So I guess what this is telling me is that okay, the variation is causing things to go really wild. So we don't really want that. We want to figure out what's going on and why should variation change that? So it must be doing something quite weird. So the variation must be going either crazily varying up and down, maybe too fast. And if it's changing too fast, then obviously we're going to get this sort of this sort of noise effect where a lot of the caves it appears to be just random numbers that are causing these caves to happen. So okay, let's have a look at this. How might this be happening? I think the problem might be that this plasma function and the scale is maybe it's sort of dividing, because the blob scale really gets used to divide these numbers. If maybe causing some kind of parallax effect, which is causing it to be way too noisy. So let's try something that's a little bit with a bit less variation. So let's put it up to like 50. Let's put in a small amount of variation. See what happens there. So if my hypothesis is correct, then and there's a parallax effect going on, then it should be relatively normal around 0, 0, but we'll get more crazy as we go out towards the edge. Oh, okay, so I've just caused a bug. What happened there? Something's null. What's null? Test. Okay, so there's a test happening. Some kind of generation is causing a null pointer error. Now, if we're testing something and we're testing it to be equal to grass, and that's null, that's going to cause a problem. So let's just fix that. If t equals null, well, it's obviously not grass, so we can just return false. Now we use null to indicate an empty block. So returning, there could be null in this test. So I was a bit careless with my checks here. So yeah, we're just going to return false in that case. Let's try this again. Hopefully this shouldn't break anything. I've got to do something a bit quicker with this world generation. Okay, so I see we're around 0, 0 with a little convex sign here. Yeah, and around 0, it's still wild, isn't it? I mean, that's not looking particularly sane. Yeah, this is just some ocean. A bit below the ocean, it's immediately getting a little bit mad. Okay, so I'm a little bit confused now why the variation is sort of sending it quite so wild. Let's have a look at this code. Though what's inevitably happening is I've just made a really stupid mistake and I put something in the wrong place. That's what usually happens when something is going really wrong. So blob scale has some blob scale noise. Pretty sure that's going to be in the 0 to 1 range. So actually, let's try this. Let's try S noise. So S noise returns noise between 1 and -1, and that if that's causing a problem, then maybe there's a problem with my 0 to 1 noise function. The usual debugging process. We're just going to try it again and see if it works any better with a slight fix, just checking whether what we did was causing an issue. Okay, let's look down, and that doesn't seem to have helped much. It's still looking very sort of broken up and noisy. Okay, so let's try this cave log variation to 0 again, just to check. That's 200 still, so that should be fine. Cave log variation scale 200 is just setting how the sort of the frequency of this noise. That's 0. That's 50. So that should always be 50. So if it's always 50, what happens? Oh, another bug. It's kind of interesting because that's in the Java hashmap class. Let me just delete the database if I've done something wrong and corrupted something. Not seen that error before, but it's very rare you get an error sort of thrown inside one of the Java classes. So, okay, so this is now back to what we were having a bit earlier, and that sort of looks quite big cave. So that's sort of the scale of 50. I think that's working. Yeah, that looks fine. Okay, so we're gonna, okay, so at 50 it seems to work fine. So that's really weird because you'd expect if there's a bit of variation it wouldn't be too different. So let's just try at 1. Basically, I'm trying to work out at what point the weirdness starts happening. And sometimes you just have to fiddle the parameters a few times just to see what's happening. Let's go underground. And there we are. It's gone crazy with just even a tiny amount of variation on that scale. So I'm really confused what's happening here. I mean, you can see the wire, that's a wire cave, I think. But like even a tiny bit of variation is causing the whole thing to go wild. And you know, I wasn't expecting that. That should be almost invisible. I think that's a big flat wire cave. Yeah, that's a wire cave. It's got a sort of like thin sort of effect going on. Okay, so what the hell's happening here? It's cave blob variation, cave blob scale. So 50 plus a noise function, which is between 0 and 1, and very slightly changing this. So the plasma function is being very, very sensitive to a very small change in scale. Let's have a look at what's happening in plasma. So scale this might be what's happening. So we sort of have this scale that's being used to divide the XY coordinate. And then we're creating these other pieces of noise with a smaller scale. Now, if we reduce the scale, that's going to you know, move the noise to a different part of the function. So there's variation in this scale, as that's what's maybe causing the problem. That's interesting. So to test this hypothesis, that in fact it's something to do with the plasma and the way that plasma is amplifying the scale for like the smaller variations, what we can do is we can say, okay, I don't want to use plasma for my isCave function. I can just use the noise, which doesn't have that sort of scale effect going on. Now let's see if that actually fixes the problem. Now I wanted to use the plasma because the plasma gives these really nice sort of cavey shapes. If we do this S-noise, it's probably going to be more round and blobby sort of shapes. Okay, so that happens as well with the S-noise. So my hypothesis is wrong. It wasn't to do with that sort of plasma thing. Kind of interesting. That's probably a wire cave. Yeah, that's a wire cave. So yeah, it's still just got really random stuff happening here. That's crazy. I might have to screenshot a few of these. So it's funny when you get world generation going wrong and you get all of this sort of crazy effects happening. Okay, let's go out of this. So it wasn't the plasma, so let's put back plasma because I quite like the sort of plasma shapes that we were going. K-blob variation. Well, if 1's too high, I mean, what about 0.01? There's got to be some point at which it starts happening. If zero doesn't have this effect, and 1 has the effect, somewhere in between, something's got to change. Now, I guess there's a technique you can use by like cutting the difference in half and keep cutting in half until you get what you want. But I had this hunch that any variation seems to be causing this, and it appears to be correct. It appears to be going crazy with just the tiniest amount of variation here. So let's have another look at this function. I am guessing that I think I might know what is going on. I think I may have made a silly mistake here. So let's put this back to what we originally wanted. So 20 to 100. if I've got this right, then there's actually probably a problem in here. Seed, S noise, seed, 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 X over scale, Y over scale. That looks fine. Noise, seed, 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 scale, seed, scale, seed. What I'm worrying about is if the scale is affecting the seed. Now, if the scale varies and then it results in a new seed, then that would obviously cause some big problems. So their seed is just affecting X and Y. That should be fine. Scale is just getting passed through here. S noise, scale is just getting passed through here. X, Y, Z, scale, seed. If I'm hitting the wrong version of the function, of course, that would cause all kinds of problems. Like if the scale is being interpreted as if the scale is being interpreted as a seed, we're definitely going to have an issue. So let's just check. This one is taking X, Y, Z, scale, and seed. This one is taking X, Y, Z, a scale, and a seed. That actually looks fine. Working plasma, I'm not doing anything crazy with plasma. Scale, scale, scale. Yeah, so what I'm worried about is if the scale is somehow getting used to affect the seed, then that would, of course, completely mess everything up. But it doesn't look like that's happening. What's this one? Plasma, X, Y, scale, seed is calling plasma X, Y, 0, scale and seed. And that's fine, but we're not using that one, are we? We're using this one directly with the X, Y, Z. Let's just double check that. Bob scale noise, X, Y, Z, scale and seed. X, Y, Z, scale and seed. Plasma, X, Y, Z, scale and seed. Open declaration. X, Y, Z, scale and seed. Oh, that's interesting. Now we're adding to X, Y, and Z. At each step. Would that cause a problem? I don't think so, because effectively what's happening is that our seed is we want to change X, Y, and Z coordinates to get to a different location in the noise function for the smaller scale variations. So I don't think that should be too much of a problem. Let's have a quick look and see. Yeah, because we're doing that with all of these noise functions. We're just, adding an amount multiplied by the seed. And it's possible we don't do we even need that in this. Oh, hang on a sec. What's this one? X, Y, Z. And that's simplex S noise. That should be fine. Simplex dot S noise. Simplex dot noise. So simplex dot noise function is just a sort of standard Perlin noise function. What's happening here? So a wire cave, if it's a wire cave, it's just doing that normally and returning true. Otherwise, it's falling through to the blob cave. So let's eliminate another sort of potential source of randomness. Then let's just check that this is still that's 20. Let's just check that this is still working. I've not broken anything else in the process. Sometimes when you're going through making these little changes, you break something fundamentally, and then of course you don't even realize when you fix the big problem. And yeah, that's back to the sort of standard blob pave sort of layout. Okay. So is cave XYZ N1 blob scale, N3 is hitting the threshold, which is a plasma noise. XYZ, I mean, they're integers, but that should be fine. I don't think that should cause a problem because Java will convert at integers to doubles automatically. Let's restore this plasma. So it wasn't a problem with the plasma function. It's happening with all of our different noise functions. We have a seed, and the seeds work. That's pretty well tested. It's just this variation which is causing it. So here's the hypothesis then. So if there is a weird parallax effect happening, okay, I think I maybe have it now. So what's happening in the noise function, we're offsetting X, Y, and Z. And the reason we're doing that is because we want a different area of the noise function. And it doesn't really matter where we move it to, as long as we move it to somewhere else in the space of the noise function. But what that is going to mean is that the X, Y, and Z that we use are quite far away from 0, 0, 0. Now, if there's a parallax effect happening, then that is going to be the problem, because if there's a parallax effect happening and you're already far away from the XYZ origin, which you would be in this case, then the parallax effect is going to be huge. So even if we're at the world origin, because these XYZ offsets are happening, I think that we may just be getting this massive parallax effect even then. So let's have a look back at this is cave thing. So yeah, so a very slight change in this scale would have a very large parallax effect if we're a long way from the origin. So we need to find a way to scale things without having this huge parallax effect going on. So that's an interesting question. I mean, one of the ways, it's parallax effect. That's definitely what's happening. So the parallax effect is if you're multiplying the X, Y, and Z by a very large amount, then a very small change in the scale will result in a very, very different XYZ coordinate being used for the actual calculation, which of course then results in you've got completely different area of the noise function. So basically any kind of variation here is going to cause this crazy parallax effect. So this is maybe not going to work the way that we're currently trying it, because the parallax effect is just going to be too big when we've got this big variation in XYZ. So we're going to have to think of a different way maybe of doing the scaling. So let's abandon this idea. let's put cave blob scale back. We know that we've got to keep that as a constant now because of this parallax effect that's going to hit us. So we can sort of say, okay, that was a bit of a failed attempt. We didn't quite get what we wanted out of this. So we need to find a different way to change the cave sizes. So I think then that what we can change instead is this threshold. So the threshold, a lower threshold is going to be bigger caves, and a higher threshold is going to be smaller caves. So let's try that. So we're going to still have this cave blob variation scale. We still need this scaling noise, but instead let's make the threshold. Let's compute the threshold. So double threshold is going to be equal to, let's just test this hypothesis, cave blob threshold plus blob scale noise. So what's that? That's between 0 and 1. Our threshold is 0.35. Let's multiply this by 0.3. So it should be going a bit above 0 to, sort of like, 0.6, 0.7 sort of level. And let's put threshold here. So we're going to be changing the sort of the threshold at which the plasma becomes caves. And we can go and change these parameters a bit later if this approach works. So zooming into our game again. So we've got constant scale on all of these noise functions now, so there shouldn't be any parallax effects happening. What's happening here? Okay, so we have caves of, we've got a lot of caves. I mean, that's just the observation right now. Yeah, we seem to have a lot of caves happening everywhere. They do look like real caves. If this thing is working, then we should get some more sort of empty areas. So maybe the best way to do it is to zoom out and have a look. So we do have some reasonably sized empty areas. I'm not seeing too much variation in the sort of the scale of these caves. They all look similar sort of size. They look quite small, and that's probably because our cave blob scale, yeah, so this number's quite small still. So let's put this up to something like 50. And what we should, hopefully this will give us some areas in which we have some really big caves, and some areas where we just get not much caves at all. Now that's looking a bit more promising. Yes. So what have we got? We've got that's a sort of medium-sized cave. Now this one's huge. I mean, this is kind of what I was expecting to see. We get some really, really big caves. So this is where the threshold is low, so you get a lot of air. And then there should be some smaller, we should run into some smaller blob caves. So that one looks a bit smaller. Yeah, so over here, the blob caves have become really small. Yeah, that's a small blob cave, that's a small blob cave. And you can see most of the caves in this area are the sort of the long, windy wire caves. And then over in this area, so this must be where the threshold has gone low, we get these really big connected caves. I'm kind of liking that. I think that's quite a good effect. You can see these little open areas. We still have the wire caves going around. That's quite an interesting one. But yeah, this is a bit closer to the effect I was looking for. Here's some really small blob caves. This must be where the threshold is, just really high, and it's only just getting hit by the high points of the noise function. Probably here as well. I think that looks more like maybe some kind of little connected blob cave than a wire cave. Let's just check this out at the side, see what it looks like. Yeah, we get that's good. We get this. We're getting nice variation here. So we're getting these big areas with no caves, and then we're getting these areas where some really big caves kick in. And I think that's kind of the effect we wanted. That's sort of giving much more interesting variation. And kind of this is what I'm looking for when I'm thinking about world generation is how do you create variety? How do you make it so it doesn't all look like it's, come out of the same cookie cutter pattern? And one of the ways that you can really make this work is by using these procedural noise functions to change the parameters for world generation in different parts of the world. You can see that if you actually look at the world from above and say, okay, well, we've actually got these hills uh, popping up. That's where the terrain height is high, and we've got the sea where the terrain height is low. That already sort of divides the world into a couple of different areas. Um, but by having the rules of world generation vary using noise functions or some other procedural generation technique, you can really create hundreds and hundreds of different combinations. Yeah. So here we have hills with some medium-sized caves below. Here we've got what have we got around here? Here we've got fairly few caves. We've got a sea with not much in the way of caves underneath. But then over this area, although we're still under the sea, we've got some really large caves generating. So all of these are going to give like a very different feel to the game, and you can sort of imagine this being a flooded cave as all the water comes pouring in, or maybe even some kind of chasm in the ocean where there's waterfalls going down into the sort of deep underground world. Um, so this is brilliant. I mean, this is exactly what we're looking for. This sort of variation of styles and variation of feeling of what the world looks like in different areas. Okay, so I'm happy with what we've done there. Hope it's been an interesting stream for everyone who's interested in world generation, and we'll be doing a few more of these as we start to add more features to the game. So stay tuned. We'll be producing more content on a semi-regular basis, and watching this game evolve into a really exciting new experience. Right.